So I'll now look at the DPU architecture, and one of the most notable points about the DPU is we've achieved this design that is able to use, as you can see here, 90% of the DSPs running at almost their maximum speed with 86% efficiency, but only using 23.9 in this case percent of the logic. And what this means is we can very easily place and route our design and achieve these high clock speeds. So you can see here that we've arranged the DPU on the VU9P into 12 engines in a highly modular design. Each DPU engine is partitioned into a square box, which means we can choose the number of engines, in the case of this device, up to 12 engines, or on a smaller device such as the VU3P, up to 4 engines. But equally, if we want to remove an engine, it leaves a perfectly uncluttered square where the user can place, or Omnitech can place, different IP, such as another neural network processing engine, so for example to address RNNs, or it could be other IP such as Omnitech video processing or custom IP. And because it leaves a completely uncluttered square, the new IP can be placed and routed at ease within this box without interfering with the DPU IP, and equally the DPU IP doesn't interfere with the other IP. So this enables very efficient system integration. In addition to the DPU engines, there is some overall shared IP, and you can see the key points here. At the heart of the DPU there is a network on chip for distribution of weights and collecting end results and so on, distribution of images. And this connects to a PCI Express interface with a DMA control and some control logic, and also a memory interface which handles, for example, the weights. But this is relatively lightweight IP, and as you can see here, because the DPU cores are also relatively lightweight, they can be placed and routed directly on top of these components, meaning we can completely fill the die. Equally, if we remove, as we said earlier, one of the cores, then it leaves it completely uncluttered for additional logic. Here we can see an example of how we can take advantage of this structure. So on the left we've got a captioning neural network design that on the very left of the diagram shows a convolutional neural network, in this case GoogleNet, feeding into an RNN, or more specifically an LSTM, which is a type of RNN, which takes the information from the CNN and uses it to generate text automatically from what it sees in the image. And over here you can see the DPU arrangement that could be used to implement that, where we've got several cores, in this case 8 cores, implementing the CNN and 4 cores implementing the RNN aspect. Omnitech has a large library of IP, as you can see here, for video and vision processing, for connectivity. We can also integrate with hard IP and FPGAs such as H.265 encoders, and we can also integrate with custom IP and create new IP for the future. And of course we can integrate the DPU with this IP. And here's an example of how this might look. For example, we see here an example that might be similar to a virtual reality application perhaps, where you've got a camera input, where you require MIPI interfacing and perhaps an IP stream containing video. We've got an H.265 decoder. We're taking the video input and putting it through our ISP IP to turn the raw camera Bayer input into an RGB picture. We're using image stitch technology to join the pictures together, and we're then feeding that into, for example, a YOLO DPU design, and YOLO is an object detection algorithm that runs on a neural network. And then we can perhaps output the resulting pictures over embedded DisplayPort. And this is the sort of design that Omnitech can create using the DPU. So the diagram here shows the DPU particularly targeted for embedded applications. Most notably here, this is based around an SoC FPGA, which generally contains a processor and most often an ARM processor. So we're using the ARM processor as the control for the DPU and perhaps for other IP. By contrast, here you can see a DPU design targeted for servers or data center applications, where the DPU is running on a large PCI Express card and the control is coming from typically an x86, perhaps Linux PC.